So I saw two new PRs this week, both from Ma Jianping. He actually has submitted a couple of additional ones that weren't performance PRs, so he's been kind of on fire this week. So one of these is for avoiding flushing too much data at once in BlueRock's environment. I think that's the right change to make. It doesn't look like Kifu's here, but the gist of it is that he saw, specifically with BlueFS buffered IO enabled, which we don't do anymore, but specifically with BlueFS buffered IO enabled, we were building up this giant amount of data to flush by calling append over and over again. And when we did eventually flush, it was this big flush event that caused a big latency spike. And so it was actually building up quite a bit beyond what our BlueFS min flush size is set to be. So his fix for this is basically to just, every time we call append, try to flush it. We already check in flush if we're smaller than BlueFS min flush size. So we don't do anything if we're smaller than that. So I think that his change is right. This will let us kind of stay closer to the BlueFS min flush size when we're doing these appends. And if it turns out that we want those flushes to be larger, we've got we'll much more consistently be able to keep the flushes at that min flush size by making this change, regardless of what we want that flush size to be. So I think this is the right change to make. So that got approved. I should put mark approves on here, actually. And then there was another PR, a little bit more complicated, for reducing buffer list rebuilds in BlueFS. That one, I think, Radek, I put you and Igor along with me as potential reviewers on that one, if you want to take a look.
Just taking a look right now. I'm not sure, even if that's the case, I'm not sure whether that's the right approach to attack. Maybe we should fix the page alignment appender. No, it's just started looking on that.
Okay. That's why I added you, Radek. Very good. All right, let's see. What else? Two updated PRs, both in RGW. This D3N cache changes. Both Matt and Mark Hogan are reviewing that. And then there's also an update, just a request for review from Casey on this ordered list map efficiency PR from Eric. And then we've got a whole bunch of stuff in the no movement category still. A couple still from Ma Jianping that we need to review, but I just don't think anyone's had time to really dig into it. It'd be good if we could figure out what's wrong with Igor's memory reduction PR. And then I still need to work on my double cache one. But that's about it as far as I could tell. Any PRs I missed here this week, guys?
Not a PR, but you mentioned the BlueFS buffered IO change, and we did a report on the mailing list this morning of some folks running into a degradation with that off during snapshot trimming in particular. It like they were seeing lots more IO to disk than they were when it was turned on.
Yeah. I mean, we turned it on for a reason back in the day. I mean, we were seeing better performance and it on, which is, kind of why we originally turned it on. But with what we were seeing with like that horrible behavior with RGW causing the OSDs to start or making the kernel start swapping out OSD memory. I don't know.
Yeah, I agree.
Yeah.
It's not really feasible to turn it back on and let us potentially swap. Um, but I wonder if there's something we could do for the snapshot trimming case to allow it to use the cache more easily. I'm not exactly sure what's going on there.
If they're seeing a lot more writes, I guess one of the questions would be, are they random writes or are they contiguous? I would assume probably they're random, but maybe not like fully random. So maybe like the buffer.
There's
Go
lots of
ahead.
more reads as well, in particular.
Okay. So I wonder then if they turned on the Blue Store buffered Blue Store buffered writes, but basically changed it so that we cache the data buffers, on write instead of just on read, if that would help them or not. Sorry, Josh, does that make sense?
Maybe. I'm not sure if the snapshot trimming would be cached there. Like if that would have an effect.
Yeah, I don't have any idea. How does that work? Does it go through what data path through the object store does that go through?
I think it ends up going through the updating the metadata about the object that is in the node. Updating some OMAP entries there for the object metadata about clones, in addition to removing the actual snapshot object itself.
Okay. So when we disable that option, right, RocksDB can't use the page cache as a secondary cache anymore. So presumably all of those reads are coming out of page cache then.
Right.
And our block cache in RocksDB is not doing an effective job in their case of actually capturing that, probably because we're polluting it with all the Blue Store ONO data. This is another case where we need the double cache PR. Okay, I gotta get working on that.
Yeah, you're right. I think this could very well be down to the metadata.
Okay, all right. I need to get that in. So,
yeah, that'll help everything, including this.
Yeah. All right, Adam, I might be bugging you soon about how to best integrate my stuff with your stuff and getting it into your thing that like updates the OSDs for your changes.
Sure.
Cool. All right. Anything else on that, Josh?
I think that's good for now.
Cool. All right. I have a quick update on the work Radek and I have been doing for ring buffer for buffer list appends. Well, yeah, and just in general. So it's all working fairly well. The ring buffer works. We also started working on making it so that when you form appends, the append buffer will grow as it gets reallocated over and over again. Previously, we were seeing that the default size of 4K was not enough in a lot of cases and causing a lot of excessive work. By making that dynamic and grow kind of like Vector does, it can greatly improve performance of appends when they're relatively large, and then also it really, in our benchmarks at the very least, seems to improve append whole performance dramatically. So here, I'll share the link for that. It's in the Etherpad, but that is here on the first slide. Unfortunately, in the MDS, which is where I was hoping to see this really help, it does seem to eliminate the extra work TC-Malloc is doing. Like it looks way better. The problem is that it doesn't actually seem to be speeding the MDS up as far as I can tell. Now all of a sudden, other areas of that thread, the MD submit thread, I believe. No, sorry, different one. Well, anyway, basically the MDS just the points of contention changed a little bit. That thread is still working very, very hard. We're still seeing a lot of contention in the MDS. So this seems to be a good change, but it's not seeming, so far it doesn't seem like it's achieving any measurable benefit in terms of raw performance, which surprises me, but that's where we're at right now with it. So I still have work to do to try to understand this more, but at least for now, the only clear performance advantage we're seeing is in the append to hole benchmark, not in the actual test that we're running. Any questions on that?
Mark, how about
Yes.
taking a look on cycles per op metric? Maybe we minimize the usage of CPU, but it exposed another bottleneck in the MDS. Maybe we are just status. Maybe we started waiting on some log.
Yes, and there is definitely lock contention involved. I see it in the traces. So it's there's other stuff. This is not the only problem. I was just hoping it would be. I was just hoping that this would alleviate it to some extent.
I see, but by micro-optimization, we really won't pacify the logs there. That makes me a bit afraid.
Yeah, I know. Me too. I still think it's a good change. I mean, just based on what we're seeing, it seems like the dynamic append length change is good, I think, because I don't see in any cases where it's really that bad, other than I guess it could use a little bit more memory. So there's that. But combined with the ring buffer, everything looks to me like it's basically better. TC-Malloc does not show up in my traces anymore. Even if it's not faster, it seems like things are better. But
maybe you are burning less CPU, but spending this time in the wait state instead of doing so, instead of crunching some encoding stuff.
Yeah. Or even maybe it's making it faster at processing requests. I should see if there's some way I can track in the MDS how many journal entries per second or something is cycling through, and maybe that would be another way to do it. But yeah, it's anyway. More work is needed, one way or another. That's it for now. Okay, so Adam, you have been working on compression testing, right?
True.
I think
I've been working on compression testing, and basically that part is going slowly and is boring, but at least one interesting piece of document I've created out of it. Basically, all comes down to intersection of two factors. One is that when compressed objects are written over, their metadata gets very long. So only few items only few objects can have their metadata stored in OSD at any time. That's one part. And the second is that for testing, I've used just random writes with basically uniform distribution. And intersection of these two factors made sometimes very strange performance results, which took us some time to understand. But it seems it boils down to a fact that if I had some test and all metadata for my data set could fit in a cache, then I had some high performance. But when at least some data couldn't fit there, the performance drop was dramatically like 4-5-fold. This is because recovering metadata, compression metadata, takes a lot of time. I mean, this is, of course, BlueStore metadata, but it's more complicated if we're running compression. And to the degree that it's like 20 times more time consuming than actually making an op itself. I mean, fetching means that we have to drop some other element in cache, and that everything is factored in that 20 times more performance consuming. So that's a background, and basing on that, I made this document which basically tells one thing. Uniform distribution is not good for testing performance in any way. I mean, not even close. Having even triangle distribution, just, triangle distribution of data, significantly improves steep changes in performance, for example, when cache is getting over some size. So, yeah, that's it. Basically, all I can do is just to recommend only using random writes if we testing if software works properly. That's the only case. Even for crude performance evaluations, I don't think it can be used, because as for example with compression, it can totally circumvent using any caches. It's like they were not even there. So yeah, that's all.
Adam, do you think that's the case even if you're restricting the size of the data set that you're testing? Because it seems to me that it's valid to test a random workload up to a certain data size, to say if you were having a random workload on some database or something.
Again, only if you're testing that your software is working properly, that there is no data, some data breakage or something like that.
You don't think there are any real world cases of like very random workloads?
I don't believe there are workloads that have uniform distribution. Just I cannot imagine any system behaving that way, unless you have just a log that writes continuously some I don't know, monitoring data that is being streamed down to the disk and never actually accessed.
Like, what about a situation in which you have many clients all performing small writes or small reads at the same time to different data sets?
That would only mean that their respective data sets have some distribution. From that, you should not expect that the overall distribution will somehow even up to equal.
You're effectively adding the distributions together at that point, right? So adding them together is unlikely to produce a uniform distribution. You're adding several non-uniform distributions.
Sure, Josh, but over time you'd expect that if you have enough of that, right, you're going to end up pushing data out of your cache to the point where you're grabbing stuff and having thrashing, I would think, unless I'm not thinking about it right.
This part is correct. If you have so many different points of access that even your large cache cannot reasonably be used more than once for every element, then you have just trashing and you can do nothing with that. But still, that would be huge amount of concurrent and not related clients to the same cluster.
I think even with like the random, I used the database example, the database you'd still see some points of commonality, like the journal for the database would be over similar objects, or the indexes would be read quite a bit.
Yeah, that's very true. So long as you don't have so many other random accesses that ends up just getting swept away.
Yeah, I guess maybe what you're getting at is that if you have such a large number of clients with different distributions, such that maybe one OSD is only seeing like a single I/O from each client, at that point, it does more resemble a pure random workload, like a more even distribution from that OSD's perspective.
Yeah.
But you'd still see some bunching on some OSDs.
Yeah, I mean, it wouldn't be totally purely random. I agree with you guys. I feel a little cautious about making a statement like this is never the case, or we know.
Well, I think it's worth thinking about like what kinds of distributions would more closely model real world workloads. I think in the past, like you've used the Ceph distributions with FIO mark to test cache tiering, right?
Yeah, exactly. Yep. We've used variations of different what are they called? Ceph distributions, I believe.
Could be. This is one of the options in FIO.
Yeah. There's a whole mathematical law around it, apparently. Zipfian. Here we go. So yes, we can do more of those kinds of tests, and that will, it'll make us look better, right? to varying degrees on how much we favor having a distribution that we keep in cache.
Yeah, and I think it depends on what the purpose of the test is. If you're trying to like isolate the behavior of one particular part of the system, then maybe the even distribution is okay. If you're trying to see what a real world user would see for their performance, perhaps we want to use a different distribution.
Yeah. Generally speaking, for development, testing cache is not super interesting. Sometimes it is, but it's the corner cases that are kind of the ones that usually bite you.
Although for something like a performance regression test, I'm not so much worried about the corner case as what a real user would see, right?
Well, but it's not the typical user that like starts complaining that everything's super slow usually. Well, maybe I don't know if that's true, I guess, but it's the corner cases that really like make people angry, right?
It could be. It could be. I mean, if a user isn't seeing any degradation where in practice, it's not always as bad a problem to solve as if a problem that we would only see if we like had an unrealistically low cache size, for example.
Sure.
Maybe is it worth?
Yeah.
I mean, is it worth adding, or do we already have like the stat perf counters to track our like cache hit rates, miss rates for our nodes?
We do have that for all nodes.
Yeah, Adam, did you record that when you were looking at any of this?
Yes, I did.
Ooh, very good.
Otherwise, I couldn't have calculated how much miss that cost.
Oh, yes, sorry, I see that now here. Okay. What is the 1.0 cache size?
It means that all metadata or all objects that are there does fit in cache.
Yes, but I mean, what size did you have it set at such that all of your data would fit into cache?
It was 12 gigabytes for 100 gigabyte of compressed data.
Okay. Was that directly setting the cache size, or were you still using the dynamic cache
No,
size?
I just put a very high limit for memory for OSD memory limit.
Okay. That probably meant then that you never ended up double caching because you never got into a situation where you're trying to read nodes from RocksDB cache.
True.
And did you try looking at cache miss probability in the I see. Okay, it is A, B, C, and D in the probability case is the same A, B, and C and D in the distributions, right?
Yes, but please note that the graphs you see there are analytical computations. They are derived from actual runs on Incerta, but only to get the model of cost of one operation. That has been actually run on Incerta. The graphs here you see, they only represent what level of degradation you will see when your data does not fit cache to the relation of some example data distributions. I can apply these distributions. I have tools for that, but well, it was obtained as I told.
Okay. So I'm trying to kind of like take all of this and think about it back in terms of compression. When you started looking at compression with a Zipfian type distribution where you don't have the same kind of random I/O across the whole disk, Did we do okay then?
I've not tested that actually. Just I was
Okay.
bouncing off having problems with bad results on equal distribution, unable to actually make it work. Just made this document and actually retesting it with some Zipfian distribution will be next step.
Okay, cool. To some extent,
taking into account your double caching, I assume that this is where that distribution must be applied. Otherwise, this double caching doesn't really make sense. It will never really work.
Sorry, what was that, Adam?
I'm thinking that double caching of O nodes both in decompressed metadata and in RocksDB will not give any significant results if our access pattern will be uniform. It will just behave strangely. It must have some Zipfian.
It will still help because you will still see the benefit of having basically twice as many random IOs coming from cache than as before, right? It gets worse the bigger your distribution is, but it will always help. It should never hurt. Does that make sense?
I will wait for your implementation.
Okay. It might be a very small effect, right?
I guess it will be a balance between how much more elements to store in a compressed form and how much will still be in a just decompressed metadata ready to use. And if we can properly strike that balance to actually get performance.
You're making the same argument I think that Sage originally made for doing it this way, which is that theoretically, if it's compressed in the RocksDB cache, you can have more data in that cache versus in BlueStore ONode cache. Is that right?
Exactly. This is what I'm thinking, and this doc I'm pushing in that direction.
Yes, and I believe that was a false assumption. I don't think it actually works. It doesn't seem like we see significant benefit to having anything in the RocksDB cache other than RocksDB, stuff that's not cached elsewhere. Which is strange, right? Because you'd think that with all of our encoding and compression and that kind of thing, that having that secondary tier of caching might be beneficial, but we must not compress enough, or perhaps because it's a block cache and we're loading a lot of like meaningless other stuff into the cache. One way or another, it doesn't actually seem to be doing much to benefit.
I think that if decompressing from block cache into BlueStore internal data takes a long enough time, then it wouldn't really matter if you cache it in RocksDB, just insignificant.
Yep. And so this is the entire premise behind the whole priority cache scheme, where we can basically say that in RocksDB with very high priority, we want to cache things like indexes and filters and potentially like ONode data or other things that are really important to us. And in the BlueStore cache and the ONode cache, we want to cache recent ONodes with very high priority, and we can start making more decisions and trade-offs about what's important to keep in memory and what's not. That's kind of the whole idea behind that whole system.
I guess when you make a double caching, we will finally see some active use of that scheme, don't we?
That's the first step, is to do that, and then the second step will be to actually finish implementing the age binning for the LRU caches, because then we can start making comparisons saying we have like 2,000 items in the onode cache that are less than 5 seconds old, and we have 50 items in the RuxDB block cache for OMAP that are this old, and how do we balance the memory requirements for those two things? And then we have a second RuxDB block cache now for BlueStore onode data that we are fetching from RuxDB as opposed to the BlueStore cache. How do we want to balance that against these other caches? And we can start then having this big kind of multi-cache memory management scheme for deciding which things get memory based on ages in the cache and how important different things are.
Yeah, I love the idea, but I don't know. It might be tricky in implementation department when my I have most concern about the fact that getting that onode data for those compressed objects gets so much time. It's so much a CPU, and that could be difficult to actually offset with any other caches.
The honest truth is that we really probably want to avoid caching things for onodes at the block cache level at all, to be honest, is my guess. We have to do it to some extent, probably. Maybe we could just turn that off, the block cache off. But, well, no, we don't want to do that. We probably want the block cache to have the indexes and filters for RuxDB in it. We just don't want it to do much with onodes, probably. Like if you have to read an onode from RuxDB, you want to make sure that your Bloom filters are in memory so that you can like quickly get through all levels involved in the hierarchy without like scanning through the entire thing, right?
True.
So you really want those Bloom filters and indexes to be in cache, but maybe you don't really care about the key value, like the block where the key value lives, to be in cache that much, because you'd rather just devote that to the BlueStore's own key value cache. But if you're going to have a miss, you want the Bloom filters there and the indexes there to like only do one disk read if possible.
This is good, but I can easily imagine a scenario when we just go a bit over onode cache size, and basically we are continuously missing onodes, just like having equal distribution.
Yes.
And then we will almost always have a fail on onode cache. And then actually having it really small doesn't really change much. It's just you're already on that very flat plateau of always missing. And instead we could save some time actually caching the other stuff. So the block cache for key value data. I mean, I'm not sure. This might be also a sweet spot of cache balance.
So what I could see possibly working in the scenario that you just gave is if we were able to say that we have something in the BlueStore cache, so don't store it in the RuxDB cache. Don't bother keeping this block in cache, because at least for this particular value, because we're keeping it in the BlueStore cache. But when we invalidate it in the BlueStore cache, then it's something that we do want to keep in the RuxDB cache. I don't think, given everything I've seen so far, that it actually works for us to have it in both, unless the BlueStore KV cache the BlueStore O-node cache is significantly smaller than the RocksDB cache. But we've seen that actually hurts us far more than it helps. Right,
No
because you have a hierarchical.
I did not test this. I did not test anything in that department, so I have no idea.
Sure. So I'll assert it is that reading O nodes from RocksDB cache is far, far, far slower than reading them from, which would kind of if you had a hierarchical cache like we're trying to do, you would hope that then being able to hit enough stuff from the RocksDB cache to not do a disk read would kind of make up for the fact that it's so much slower than reading from KV cache. But it doesn't seem to be the case. Like especially with NVMe drives, reading from the block cache doesn't seem to be all that much faster than just reading it directly from NVMe, whereas the BlueStore O-node cache directly is significantly faster. Maybe it's because of our encode overhead, maybe it's RocksDB, who knows. But one way or another, it looks like you're almost better off just giving as much memory as you can to BlueStore's cache and just kind of almost bypassing as much as you can the RocksDB cache. That's what I've seen anyway.
Yeah, I accept that, but I'm just thinking if we really do have a hierarchical cache there, because on each level we store a process data. So could we really think that all that theory of hierarchical caches will apply to this?
I'm not. Sorry, are you advocating that we? Go ahead.
Sorry.
No, I was just wondering. So, are you advocating that you think the hierarchical cache could help in this case?
No, I'm not sure if all the things I've learned about hierarchical caches, if I should not reevaluate them, because clearly I see that in our situation, it's not the typical case. The typical case that I learned is that the same data is stored in a gradually closer to the place where the data actually is used by each time a bit less. But in our case, this is not the same data. We have different thing in O-node cache, different thing we could have in KV cache, and different in block cache in RocksDB. So additional factors in calculating the performance of the whole solution.
Oh, one thing that I forgot to mention too, now that I'm thinking about it, is that I believe when you go through a compaction cycle, you end up invalidating almost the entire block cache. Because you're going through and you're basically loading all of this stuff into the cache to do your compaction, and then a lot of stuff gets invalidated before you reread it back in. I remember seeing that when I was going through doing a lot of the testing.
That makes me want to make a nice test. What if I can actually use this in testing? So having some O nodes cached and see how for a short time my performance will drop because I no longer have those block caches. That could be interesting. I should be able to see that in some test scenarios.
That reminds me that this is one of the reasons why I was so kind of gung-ho back like a year ago on trying to make an OMAP cache in BlueStore along with our ONode caches, is to do that at the BlueStore level and then just have RocksDB block cache be very small and only for indexes and filters and small amount of data for compaction to keep SST files in the cache for doing compaction event. That'd be a lot of work though.
Yeah, I don't even have an imagination at that time what should be actually changed to do that.
Imagine though that if you could do cached OMAP reads without doing any encoding and decoding.
No, my discussion ends here. That's that's too much for me.
It'd be faster, I think.
Basically, I would love it. I would love to have just the same format, both on serialized and in memory. That would be like perfect.
It'd make Matt really happy too, I think. But it'd be a lot of work. So maybe we're not there yet. I'm sorry, Adam and I have been dominating this conversation. Josh or Neha, any thoughts on any of this?
Well, we covered a lot of different areas, I guess, but maybe going back a bit to the idea of performance regression testing. Sounds like another metric that we could be tracking there is looking at how many cache misses are happening, or what our cache rate is, hit rate is in a test, to see if that is like one of the factors of causing a difference in performance.
Yeah, that would be a really good idea because we are so sensitive to ONode cache misses that really that oftentimes is kind of a determining factor in performance that we see.
Mm-hmm. I wonder if that could explain some of the variation that we see with those results too. We just happen to have more misses in some cases.
Could be. A lot of times I try to, unless I want to look at a case where I'm seeing cache misses, I will actually try to test against a data set that I know fits 100% in the OSD to eliminate those kinds of variations so I can really only focus on the thing I want to test.
Yeah. I guess in the extreme case, we could turn off the cache entirely if you wanted to avoid any kind of effects from it.
Or you just run your data set so that it will fit in the cache so that you're not your performance isn't dominated by like RocksDB reads of ONodes.
Right. I guess then that hit rate would tell us whether that was happening or not, right? Or it's somewhat.
Yeah. My guess is that unless we're picking a large data set per OSD, most of our existing tests probably are all fitting inside the cache. That might not be true if you have a really heavy OMAP workload, but like for an RBD test against like something that's a data set that's smaller than like 128 gigabytes, I believe it should typically fit into a standard 4 gigabyte OSD memory target size.
What about the greatest bench tests that we're doing? I guess those are using like new objects all the time. That's a bit of a different case.
Yeah, do you remember how much data they're writing up?
I'm not sure. I'm not sure if they're using the defaults or not.
Sure. With small objects, you definitely will use a lot more OMAP data and just data in general for RocksDB. So like if you write out 256 gigabytes of 4K Rados objects, you'll blow past this.
Right. And do you remember how we're limiting the runtime there? Are we just like running Rados bench for a certain amount of time or a certain?
Can you repeat the question? Sorry, I was a bit distracted.
For the perf CI stuff, do you remember
we
how
are
we're running?
I think 300 seconds is the time that we use at the moment.
So Josh, 300 seconds. Neha, what size are the objects?
We have all combinations. I can pull up the entire matrix if you want. Just give me 1 sec. We have 4K, 4 MB.
So the 4 megabyte size is uninteresting as far as this goes because that won't be nearly enough metadata to make RocksDB upset.
Yeah, you got it. Paste it in the chat. For Rados bench, we have 4K, 4 MB, and we have different kinds of random read, sequential read, write, and OMAP write as well.
So 300 seconds of 4K writes. I'm going to hazard a guess that we are not doing that fast enough to blow past the caches. No, I don't know, maybe.
Well, if we do 300 seconds, then the problem is basically out. If we go to the limit, we just hit a lot of penalty and still not really see it. It's just 300 seconds. We'll just do less ops in that time. So that's it.
So one quick question is there. So we talked about the cache hit and misses metric. Is that something we can expose using CBT? Then these tests could easily capture that whenever they run. So we can compare if 300 seconds is enough.
Oh yeah, absolutely. All someone would need to do is write something into the monitoring to periodically grab the perf counters that we want to write out. Sorry, Adam, were you saying something?
No, sorry, I had a bad case of latency.
Oh, okay. Yeah, Neha, I think all it would take would be someone writing a monitor, module or whatever. I forget how we're doing it now. I think someone was going in there and improving that.
I know. Radek, do you remember there was somebody who was working on their stuff, adding more metrics to CBT?
Avnum, I believe.
Okay. Can we check with him if it's something that he would be interested in adding to CBT?
Well, I talked with him yesterday. The main idea is about using CBT to monitor Crimson and gather some C-star metrics from it. But I believe we can do that in a way that could be reused in other scenarios as well. As far as I understood you, all it boils down to just collecting some perf counters of Ceph during a CBT run, right?
Exactly.
Yep.
Sounds doable. But would it be enough to collect on start, at the end, or on some interval?
Radek, I think there's a bigger discussion about triggering monitoring down the road, making it so that some event can trigger, certain monitoring. But for now, I'd say let's just, at the start of a test and end of a test, start it and then end it.
Yeah, that would be the most straightforward way.
But I think someday it would be really nice if we could trigger it. Like if you had some way to kind of tell CBT that on a certain event you want to all of a sudden enable perf and block trace and other things.
I see, but at the moment we are lacking such interface, I believe.
Yep, exactly.
Okay, I see.
Does that sound good to you to be able to monitor just throughout the duration of to start out with, to monitor through the duration of a given test?
Yeah, absolutely.
So I suppose maybe just spawn a thread that then goes and like every second or something calls, no, maybe even second is too much. Maybe every 5 seconds or something, or configurable, goes and does a admin socket dump against, well, maybe all of the OSTs, or maybe you specify which OST you want, and then does that.
And now that the admin socket commands are unified with the tail interface, you don't have to be on the local node to do that. You can just go to the monitor and collect from whatever OST you want.
Yeah. Josh, when it does that, does it just then read a local copy from the monitor, or does it actually go out and collect it from the OSD?
Oh no, it has to collect it from the OSD anyway, but it just means that you don't
Okay.
have to be on that node.
Yeah. And does it go through the monitor, or does it actually somehow directly report back to the client?
I forget if it's proxied through the monitor or not, or if it's.
We may. Oh, go ahead.
Yeah, I'd have to check the code. I can't remember.
We may want to grab it directly from the daemons, and then at the end, grab those results and pull them back into the results directory, simply to not, require the extra overhead of going through the monitor.
Sure. Yeah, simple enough either way, I guess.
Well, in any event, we are past end of the meeting time here. Good discussion. It was very interesting. Adam, thank you for presenting on your work.
Thank you for being so honest with your attention here.
All right. Well, anything else, guys?
Nope. Thanks for the discussion.
All right. Have a great week, everyone.
Yeah.
You too.
Thank you. Bye.
Yeah.